All right, the first thing we need to get into on your notes are your radical parts or parts of a radical. All right, so things you need to make sure you identify or should be familiar with, okay? If you want to get a highlighter, get one out. You will still need to identify the coefficient because that's important when we get into our rules. We do not mix the coefficient with the radicand. So the number on the outside or in front of the radical symbol is the coefficient. You should already know the radical symbol. I'm not really going to stress that. Okay? This is not important. Yeah. There's, I think, by the computer. And then radicand is probably the first new term. And your radicand is actually the number that is underneath the radical symbol. Okay, it has to be inside. We call it inside the house and outside the house. Okay. All right. So this is just a fact that occurs, and we're going to use this in our rules. No coefficient means blank in front. No means what in front? No coefficient though. If it's no coefficient, what would it mean in front? What would have to be in front? If it would have to mean that there's a 1, okay? Or you could say no number in front of the radical sign. When I mean in front, we're talking about in front of that symbol. Are we okay with that? Outside. And we do not mix the insides and the outsides. That's very important. We're going to hit that hard today. Okay? All right, so some prerequisite facts or skills that you should know, and I'm not really going to stress this filling in everything you are, but I'm not. All right, you should know the following perfect squares by heart. So the first, we should have 4, then we should have 9, right? These are the perfect squares you need to know by heart. Like as soon as you see them, you should be able to factor them, simplify them. Coach, you told me 13 squared a while ago. What was it? 169. Good. All right. 14 squared. 1. Oh, I skipped 12. Sorry. 144. 196. What was 15 squared? 225. Okay, these are the ones that I need you. Basically, what I'm going to put here. All right, these go. They're interchanged. They go together. This is what you need to memorize. This is what will be part on your like 60 or minute check. All we want to make sure that you know, if you know the perfect square, that you know its square root. So the square root of 4 would be 2. Okay, do you see how these just go together? Dot, 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 dot. I'm not filling that in. Okay, just make sure you know these 2 boxes by heart. You probably already do. So just make sure you do. Continue to know them. All right, what we're going to get into is the rules for simplifying radicals. Okay, I know this is part at the bottom of your page. All right, the method we're going to use to simplify, and I know there's another method, and I'm only going to address it if you know it and want to, I guess, master it, will be factoring the highest perfect square. This is the most efficient method. All right, for step 1, you're going to break the number inside, which is the radicand, into 2 factors. With the first one being the highest perfect square. This is why I'm asking you to make sure you know your perfect squares by heart, because you're going to have to use them to factor your non-perfect squares, your radicals that we're going to simplify. All right, step 2 is basically we're going to pull out the square root number, place it outside the house or outside the radical symbol, and leave the rest inside. Okay? Perfect squares are going to come out. Everything else is going to remain inside. Now, here's the example they gave you. To simplify the square root of 48. Now, we have factors 16 and 3 and 8 and 6. Do they both give you 48? Yes, they do. Okay, now it says use 16 and 3 and not 8 and 6. Why shouldn't we use 8 and 6? Yeah, 16 has the perfect square. Is 8 a perfect square? No. 6 a perfect square? No. So we have to use the highest perfect square. We have to use a perfect square. All right, so the square root of 16 is what? 4. That's why that came outside. See how it's in front of the radical now? Okay, and then whatever it is not that remains stays inside. Outside and inside never mix. Okay? You multiply them together. That's a good question. If there's two outsides, or if you already have a coefficient, you multiply to what's already outside. Okay? So, we're going to practice this rule. All right. Mentally. We're going to practice it mentally. We're going to show some steps, and I'm going to show you how you get partial credit when simplifying. But some of them you're going to just start knowing by heart. All right, what's the square root of 196? All right, so that's done. Okay, now, square root of 48. Close. 16 times 3. So this is what you have to write, because it's not a perfect square. So we're going to use 16 and 3. Yep, so 16 is the perfect square, so that comes out. So that's 4 square root of 3. 4 times the square root of 3. Now, this is what Coach was asking right now. Who's the coefficient right now? 3. That's on the outside, all right? So that stays on the outside, okay? Then we're going to factor 12 using the highest perfect square. No, 6 a perfect square. 4 times 3. Okay? So, 4 is a perfect square. What do we do with the perfect squares? It goes on the outside. Who's already outside? The 3. So this is going to be 3 times the 2, because that goes outside with the 3. And the 3 remains inside from the factor. So 3 times 2 will leave me with 6 square root of 3. Or 6 radical 3. Or 6 times radical 3. Number 4, negative 48? No, that's too big. Let's see what we have. We should have negative 24 root 2 for 4. Questions on that one? All right. Here we should have 15 root 3, or square root of 3. 15 times square root of 3. All right, because you have to multiply the square root, or the perfect square, to the coefficient. All right, on 6 root 2. You want the perfect square way? Okay, so you could use the factors for 72. 36 times 2. And then the square root of 36 is the 6 that comes out. Did you use a different factor? Because I think I had some people do 9. Yeah, so you could start off this way, and then the 3 would come out first, right? But then the 8 can be factored some more. Yeah. Which would give you still end up with the same answer. Okay, all right. All right, so, Kosi, what'd you get for number 7? 3 square root of 2? Yeah, okay. Okay. Charles, what'd you get for 8? Yep, 2 6. 2 root 6. 2 square root of 6. All right, number 9. Mason, what'd you get? Yep. 4 square root of 2. Alabama. Yeah. Who do you think? What does he wear? Almost them. All right. 10. Christian, what you get? Yep. Jordan got 11? Yep. 15 root 2. All right. Do we have any questions on simplifying? All right. That's the first skill, or first check. Now, tomorrow, guys, listen up. Tomorrow, when I give you your perfect squares and the square roots, you're going to be expected to simplify now. Okay? On your mini check. All right. All right, so go to the, or look at this pattern real quick. Okay. Now I'm going to show it to you, and then I'm going to show you a shortcut. Variables, guys, when dealing with variables, they're a little different than when dealing with numbers, okay? Um, Here, like, this has an exponent of 1. The square root of x to the first power is still the square root of x. But the square root of x squared, which basically means x times x, it's now just going to be x. When I take the square root of x squared, that's going to be x. Okay? Now, look what happens for the square root of x to the third. X to the third is the same thing as saying x squared times x, or 2 plus 1 will give me a total of x, 3 factors of x. So this final answer is going to be x times the square root of x. The 2 plus the 1. Okay? All right, on the 4, the square root of x to the fourth is going to get simplified to just x squared. So what would happen to x to the fifth? You could do x squared, and x. Yes, you could do it. Anyone see a simpler way? There's another one. Yes, you could do x to the fourth and x. That would work as well. See, those both patterns work. And so I'm combining the two, right? X to the fourth is the x squared, and my x that remained it was just the square root of x. Okay, now, what about x to the sixth? I could do x squared, and then x squared, right? Or I could say, yes, I could also say x to the fourth and x squared. Or when I take the square root, it's going to be x cubed. Yep. Okay. Now, so what would be the answer for the square root of x to the seventh? X cubed, that's right. And then the square root of x. Think about it. What's x to the sixth? That's x cubed, right? When you take the square root of it, that's 6. And then I need one more. That would have to be x, the square root of x. I'd use previous ones. Like I know what x to the fourth is. It's x squared. And then if I'm going to have an x to the fourth compared to x to the seventh, that means I have a 4 plus 3, right? 3 more. 4 and 3 is 7, right? So if I had x to the fourth times x to the third, that would give me x to the seventh, because 4 plus 3 is 7, right? I'm going to show you a shortcut, but I'm just taking this is a perfect square, right? I know what the square root of x to the fourth is. It is x to the second. And I know what the square root of x to the third is. Yeah, and so I'm putting these together. I'm using a perfect square, and then I'm using my remainder. Now, here's a shortcut. All right. This symbol, this radical symbol, is dealing with what type of numbers? When do you use this radical symbol? Square roots. Okay. All right. You're dealing with squares. Okay. So, meaning that what would be the inverse of this symbol? The little thing to the second power. Does that make sense? Those are inverse of each other. They cancel each other out. Which means, okay, that this symbol has an index of 2. We're always dealing with groups of 2, factors of 2. Does that make sense? All right, so here's the shortcut whenever dealing with variables. Okay, if I have a letter, let's say we have A, and I'm dealing with to the ninth, okay, exponent of 9. And I'm talking about the exponent of 2. My index is 2, so basically I'm trying to ask myself, 2 can go into 9 how many times? 2 can go into 9 how many times? 4 times. 4 times, because 2 times 4 is 8, right? Okay? And then plus you would need another one, right? To get 9. So that means you would have 1 left, right? Okay? Or you need 1 left. And actually, we did this. So you ask yourself whenever dealing with the variables, how many times can 2, because we're squaring it, how many times can 2 can go into the exponent, and whatever your remainder is stays inside the radical, okay? So here, how many times can 2 go into 3? 1. So that comes out, huh? It'll be y, z squared, y. Because 2 goes into 3 one time with the remainder of 1, right? The remainder is what goes inside the radical, okay? How many times can 2 go into 22? 11. So that means this is a to the 11th. And then, can I take the square root of 3? No. So that stays inside. Okay? We're going to keep on practicing. Let's go to the next page. Oops. All right, so think about this. Here we go. Square root of y to the second. That's just y. 2 can go into 2 one time. All right. Now I'm going to do each one. A squared b. It'll be a square root of b. B stays inside. Okay? C squared, d squared, and then d. Inside. Okay, 2 can go into 5 two times with the remainder of 1. The 1 remainder stays inside. Okay? All right, so this would be K 50, right? 2 can go to 150 times. Now, if it has a coefficient, it stays on the outside. Anything we take out goes with that coefficient. All right, so we're going to go to the number. What's the square root of 4? 2. That 2 comes out to this 2 here, so now we have a 4. Okay? What's the square root? Oops. What's the square root of x? Yep. So we have an x, y to the third, z to the fourth, then y, z. You're right. The remainder stay inside. Yeah, if you have the number, do the number first. Yeah, all right. So, all right, r to the second is already on the outside. We want to factor the 40. What can I do for 40? 4 to 10. Yep. So we have 4 and a 10, and then we have all this other stuff. All right, so this perfect squares come out. So we have 2, and then r. R to the what? We already have r to the 2. R4. And then S6, yes. And the square root of 10. That is correct. Okay, are y'all having questions on the 4? Yeah, you just add. Whenever you have exponents, okay, with the same base, because they both have r, you add the exponents when you multiply, okay? All right, so this last little rule, we got to make sure we finish this, okay? And hopefully we'll probably get further ahead. All right, adding or subtracting. Now, adding, subtracting radicals is just like you did in algebra when you have to have like terms. Y'all understand? Y'all remember adding like terms? They have to have the same variable in order to add it. Okay, this is going to be the same thing. You must have the same radicand in order to add or subtract. So basically, you're going to do the same thing. You need to have a like term. Okay? If the radicands are not the same, then try to simplify them first. Okay? Add and subtract the outside coefficients, leave the radicand as is. Okay, just like dealing with denominators with fractions. Okay, only add what's on the outside, keep what's in the inside. So the first thing you have to do, the radicand or inside or like terms, is you look and see what number is inside or underneath the radical, and you check to see if they're the same. Are these the same radicand? Okay, so now that they're the same, all you're going to do is add the coefficients. Yes, yeah. So this would be simplified as 8 square root of 7. Okay? Now, so do the next two for me, because now that you know they have to be the same to add them. you can go ahead and simplify. All right. So hopefully we got 4 square root of 2. Okay. And then what about 20 when we subtract? Yeah, 4 square root of 6. All right. If I don't have a coefficient, remember it's like if 1 is there. Okay. Now, here, where's my, there we go. All right, so on 21, do you have like terms or same radicands? No. Okay, so the next step you have to do when they're not the same is you're going to try to simplify it so they do become the same. This is the smallest one is always a clue. That's basically telling you what you're going to use exactly. Okay, so 2 root 3. I'm now going to simplify the 12 using the 3. So that would be 3 times 4. Wouldn't that give me 12? Okay. Yep. So now I can take out my perfect square because that's the only thing that can come out. So we have 2 root 3 plus 2 root 3. Now are they like terms? Yep. Now you can add them because they both have radicand 3. So this would be 4 root 3. That's the answer. Okay. Try 22 right now. I need you to see if you can get to the same radicand, same like terms, so you can add or subtract. All right, so we know this can be reduced to 3 root 5, right? So this gets reduced to 12 root 5. Are we good there? All right, now, multiplying and dividing. Okay, this is the part that I'm hoping if you understand what's inside and outside, this won't confuse you. But here's where some people make mistakes. Okay? All right. Phrase that pays. Inside to inside, outside to outside. You can sing it, you can rap it, you can screw it, I don't care. Okay? But you need to understand that you do not mix the insides and the outsides. I look at it as inmates and outmates. Inmates and outmates don't mix. Okay? All right, so you will multiply the outside numbers together, and then multiply the inside numbers together. Whenever you're dealing with multiplying and dividing, keep the two parts of an answer separate, outside numbers together, inside numbers together. And then always simplify the final answer if needed. So, who gets multiplied together on 23? The 2 and the 8, because they're both inside. Does that make sense? All right. What is 2 times 8? 16. And what's the square root of 16? And that is your final answer.
Wait, this cancels out each other. Remember 25?
Yes, so what's your final answer? Yep, 5 is the final answer. Because whenever you take a radical and you square it, it cancels out the radical. And all you're left is with, or I can show you. This basically says I have 2 factors of the square root of 5. Square root of 5 times the square root of 5 is the square root of 25, yeah, which is always going to end up being the number. Okay, so whenever you square a radical, it's just the number. It'll end up being just the number that's inside the radical. All right, what was 24? Square root of 6, okay. And now, what about 26? 18 radical 2? Yep. All right, first one gets multiplied together. The 3 and the 2. And then the 6 and the 3, right? So this would be 9 radical 18, right? Yeah, the 18 square root of 2 is the final answer. And then the square root of 18 gets simplified to 9 and 2, right? It's 27 what? Yes, how'd you get that?
So 40, so 39, and then 39, square root of 9 equals
3, right? So you didn't, yeah. Square root of 3 times the square root of 3 equals the square root of 9. When you take the square root, it comes to 9. Oh, you talking about this here? Oh, I thought he was referring to that question here. 9 times 2 is 18. Oh, my bad. Yeah, it's 6. So this would be 6 times 3, which is a root 2. Okay, I need you to talk about this. The last one. This radical, okay, this exponent of 2, excuse me, is going to the outside and to the inside. It's going to the radical and to the coefficient. So this is saying 7 squared and the square root of 3 squared. Because you're applying it to the whole thing. So what is 7 squared? 49. And what happens when I square a radical? It cancels out. So what I'm left with? 3. So this is 49 times 3. Which will leave you with 147. Okay? So try 28. Okay? You have to square the coefficient and you square the radical.